Hello everybody, greetings from California. I couldn't be with you today, but I wanted to help you guys study for your test because you guys learned a lot this unit, and I want you to be able to demonstrate all that stuff that you've learned. Now, this unit's on motion. You already have a review sheet. Hopefully you've already started studying. Okay, we've got the video on here. The first video, first reading, okay, section 1, section 2. We got the vocabulary from both those sections. We've got the second video and the reading, vocabulary from there, some skills that you need to know, and the lab topics you need to be familiar with. Remember, the format of the test is exactly the same as last time. 10 matching, which are all vocab, bolded words from the book. You can also study from the Quizlet that I sent you via email. There's going to be 15 multiple choice. Oops. Change that. 15 multiple choice. Oh, can't. I gotta enable editing. There we go. 15 multiple choice from the videos and reading, and then 2 out of 3 essays. You have 3 essays. You need to do 2 of them. All right, and that one bonus essay, you should at least attempt. Okay, never turn down bonus credit. Okay, in case you lost this review sheet is also on Blackboard. See it right there? It's right at the top of Blackboard for you, so you can study or reprint it, whatever you need to do. Okay, but what I did is I just transferred it all to a PowerPoint right there. Okay, and we're going to break it up into 2 classes. So let's start from the beginning. Here we go. All right, and break it up into 2 parts, 2 videos. All right. Quick review. This is the first video that we looked at. First thing you want to know, scalar versus a vector quantity. Scalar, where's my mouse? There it is. Scalar measures the amount only. It's like a scale. Okay, no positive or negative, no direction. Vector quantities, we like these in physics. We want to use these in physics. It gives not only the amount, like 6 meters, but it gives us a direction, east, west, north, south, up, down, left, right. Okay, that positive and negative sign tells you the direction, away from the point of origin towards the point of origin. All right, and these vector quantities can be added and subtracted. All right, and super useful in using in solving problems. Scalar quantities are like speed, distance, time, mass, temperature, pressure, no direction to them. Vector quantities, we love displacement, we love velocity, we love acceleration. We'll do the other ones later, force, weight, and momentum. But physics loves vector quantities. Vector quantities give you more. Okay, so let's look at 2 vector quantities, distance and displacement. Okay, distance tells me the path it takes me between 2 points, whereas displacement gives me the distance relative to the origin in a straight line, and it tells me the direction. Okay, so we like displacement. It gives us more information. All right, it can be positive or negative displacement, and it's usually abbreviated S or X for position or change in your displacement. Okay, displacement vector, distance, scalar. Okay, you've seen this. This is the example from the book. So what is velocity? How is it calculated? Velocity, okay, is speed plus direction. It's the rate of how much you are displaced in a certain time. So if I graph it, here's my position, here's time. Notice my position changes. I'm at 20 centimeters at 0.1 second, but I'm at 40 centimeters at 0.2 seconds. So my position is changing relative to time. Okay, so if that changes, then I have velocity. I am moving. It's a ratio of the distance traveled over time. And if we have displacement, positive, negative, we know which direction I'm moving. Right? So when I graph displacement versus time, the slope of this line, change in y divided by the change of x, is going to equal my velocity. If If it's steeper, I have a higher velocity. If it's shallower, I have a lower velocity. Okay? If it's negative, I'm moving away from the point of origin. If it's really steep negative, I'm moving away from the point of origin really, really fast. Okay? All right. Notice here, if I'm not moving at all, my position doesn't change. My displacement doesn't change. Velocity is 0. If I see a curve, that means I'm covering more and more distance with each moment in time. Curves mean acceleration. Positive change means a positive velocity. Negative change would be a negative velocity. Okay. Remember, velocity is measured in meters per second. Displacement measured in meters. Time measured in seconds. Units are important. Cool? Okay. So, along with video 1 goes section 1 of the book about choosing a frame of reference. Okay. You want to choose objects to refer to that aren't moving. Okay. That way we can have a common perspective for solving problems. All right. When I measure distance, what do I want to use? I want to use meters. And distance is the path that I take. So if I have 2 points and I walk along this curved path, that's my distance. It's the path traveled. How is that different from displacement? Displacement is the direction and length of a straight line between those 2 points. Okay? So displacement is more specific. Okay? Now, what happens if I want to combine displacements? Displacement is a vector quantity, so I can add and subtract vectors. So if I go 2 meters east and then I go another meter east, I've been displaced a total of 3 meters. I add up the 2 arrows, whoops, 1 arrow, 2 arrows, end to end, and it gives me my resultant vector, or my total displacement. Now, if I go the opposite way, I change my direction. I change my motion, come backwards. I go 2 meters east, then 1 meter west. Well, now I have a negative number. Okay? 2 meters plus a negative 1 meter gives me a total displacement of 1 meter. Although I've traveled 3 meters, my displacement is a net result, or a resultant vector, of 1 meter. Now, I can also do this if it's not in a straight line. I can go 3 meters east, 2 meters north, and now I have a resultant vector of displacement where I put those 2 arrows together, tail to head, and when I draw that arrow in, that's my resultant vector. Now, you need a little geometry to do this. Don't worry about it, but I want you to know that you can do this. And this resultant vector, it's got to be longer than 3 and longer than 2. Okay? Do you need to know how to calculate it? Not necessarily. You can count if you want to, or you can logically deduce what that is. But this is, remember that picture in the book from the boat? That's what this is showing. Okay, it's going across the river. It's going up, but it's getting pushed by the current. All right. So velocity. What happens when it changes? All right. Velocity can be constant. Remember this from that second video, but it can also change. I can go super fast, or I can go slower and then speed up. Okay. When I do that, my velocity is going to change, and I'm going to accelerate. But I can also accelerate by going the same speed, but changing my direction. Okay. Velocity is speed plus direction. So when I change either my speed or my direction, I'm accelerating. Okay. Acceleration is any change in velocity. Speeding up, acceleration. Slowing down, acceleration. Sometimes we call that negative acceleration or deceleration. Once again, I'm going quick because this is a review. You've already had this. You've already seen this. But it was 2 weeks ago, so I just want to refresh your memory. All right, so acceleration is a measurement of how that velocity is changing. Right? If it speeds up, it's positive. So you can go 0 meters a second, 10 meters a second, 20 meters a second. I'm getting faster. I'm accelerating. Or I can slow down. 100 meters a second to 70 meters a second to 40 meters a second. That's a negative acceleration. Okay? Because I'm changing my velocity in a negative way. It's getting smaller and smaller and smaller. How do we calculate this? Just like we did for the lab. We took our final velocity minus our initial velocity divided by our final time minus our initial time. Because we might change in velocity divided by my change in time. You will need to be able to calculate an acceleration for the test. We did it in the lab. You're going to have to do it again for the test. So figure out how much your velocity is changing, how much time it takes to make that change, divide the two. All right. Now velocity is in meters per second. Time is in seconds. So I get a meter per second, which is a meter per second squared. Okay, cool. All right. Well, when objects fall, they accelerate. And near Earth, they can go into free fall. All right, where the velocity is going to increase over time. They don't fall at the same rate. Okay, the velocity gets faster and faster and faster until they reach something called terminal velocity. But we'll get to that later. Okay, they do accelerate at a universal rate. Okay, 9.8 meters per second squared. We're going to round in all of our calculations to 10 meters a second. So it starts off at rest. After 1 second, it's sped up to 10 meters a second. After 2 seconds, it's going 10 meters per second, and now it's going 10 meters a second faster, so I'm at a total velocity of 20 meters a second. After 3 seconds, going 30 meters a second. So I'm getting faster and faster and faster. I'm accelerating. Why? Because gravity's pulling me down. This is called free fall. Okay? Whole section in the book. Let's stop there. Okay? If we're going to do both videos in the same class, take a 5-minute break. We're going to do one video today, one video tomorrow. Okay. Take a bigger break. Switch gears. Go back. Look over your notes. Go back. Look at Quizlet. Quiz yourself on those vocab questions. Pause the video now. When you're done with your break, come on back. We'll do part 2.